Have you ever wondered how all the residents of a city get their water? Perhaps you've noticed the giant water towers on the outer edges of a city skyline. Individuals in homes miles away only have to turn on a faucet handle for the water to flow out of pipes and into their kitchen sink. The simplicity of that system should be near and dear to all of our hearts, both figuratively and literally. The water tower system is known as modern plumbing. The body's method is called the systemic circulation system. Modern plumbing, like our hearts, is a circulation system with a pump that depends on pressure. To maintain that pressure, it requires three elements to function: a container, fluid, and of course the pump. In the body, your arteries and veins make up the container. The blood is the fluid, and the heart is the pump. These elements are a three-legged stool. Any failure or disruption of one of those, and the stool tips over. You spent an earlier chapter studying the body's fluid, aka blood, so hopefully you are pretty well versed on its components, plasma and formed elements, red and white blood cells. But did you know that the body contains 4.5 to 6 liters of blood? Need a visualization of that quantity? Picture 1.5 gallons of milk. That amount of fluid is important. The body can handle some loss, but trying to run your body without blood is like trying to run your car without oil and gas at the same time. You're heading for a crash and burn. So now let's talk about the body's container, the arteries and veins. Arteries and veins are the major distribution highways of your body. Because your blood is carrying oxygen, nutrients, waste, hormones, heat, and other resources the cells of your body depend on minute by minute, the highway system has to be extensive and efficient. Oxygenated blood is carried by the arteries and travels away from the heart. Veins carry deoxygenated blood to the heart. Just like the road system has interstates with exits, small streets, and driveways next to homes and businesses, the body has its own system. Instead of smaller and smaller roads, the body's major interstates or arteries lead to smaller arterioles, which lead to permeable capillaries where oxygen and nutrients leave the blood and are exchanged in the body's tissues. Carbon dioxide and metabolic waste leave the tissues and re-enter the blood to be brought back to the heart and lungs to be reoxygenated. Pressure is partially maintained by keeping a consistent amount of fluid in the container. So how does the body get all of the nutrients, oxygen, and carbon dioxide exchanged outside of the container without losing too much? Thankfully, the body has a backup piping system that collects the fluid that leaks out during the exchange. This is called the lymph system and also plays a role in your body's immunity, but that discussion is for a later chapter. Last but not least is the heart, the body's pump, which is responsible for moving and distributing blood from your head to your toes. The heart is divided into two sides, right and left, by the interventricular septum. The sides are further divided into top and bottom chambers. These chambers are called the right and left atria and right and left ventricles. The heart collects deoxygenated blood from the body through the superior and inferior vena cava. This blood drains into the right atrium. The top chambers of the heart contract, and the collected blood is pushed down into the right ventricle through the tricuspid valve. Then the bottom chambers of the heart contract, and the tricuspid valve slams shut, resulting in the lub sound that can be heard through a stethoscope. The blood is pushed from the right ventricle through the pulmonary semilunar valves and travels to the lungs via the pulmonary artery, where it circulates, exchanging carbon dioxide for fresh oxygen. The oxygenated blood returns to the heart through the pulmonary veins, which drain into the left atrium through the bicuspid or mitral valve. Again, the top chambers or atria of the heart contract. The pulmonary and aortic semilunar valves slam shut, resulting in the dub sound as the blood is pushed into the ventricles. The ventricles contract again, pushing the oxygenated blood into the aorta through the aortic pulmonary valves, where it circulates to the rest of the body. In the real world, the failure of plumbing and the body's systemic circulation system have consequences. If the pressure drops in your home's plumbing, the hot shower spray may become more of a drizzle. In that case, you call a plumber who looks for a leak or a broken pipe or a faulty pump. When a person's blood pressure changes to be too high or too low, paramedics, nurses, and doctors rapidly search for a wound, internal bleeding, or a heart blockage. Most of the time, our body is capable of maintaining its own plumbing through a system of hormonal checks and balances. However, when these checks and balances fail and help is not received, the result is flatline.